Hey everybody, we have about 55 seconds to the contest. Hope everyone's having a good day, good night, wherever you are, however you're doing it. Uh, yeah, wish me some luck. I actually have time to set up, but also if you enjoyed this, hit the like or subscribe or whatever people say. Yeah, I did the earlier contest today. I did okay, so hopefully I'll do stay consistent and do just as good or just as well. Could never tell. But yeah. Okay, 20 seconds. So yeah, wish me luck, because I'm going to need it. Get my papers ready, my everything set up. I could set up enough. Okay, let's go. Let's go. Yeah, shift 2D grid. So the first thing I noticed here when I read the problem was that the shifting the way k times. I actually didn't even read through it that much, so I was like, okay, let's do this. It just seems like simulation. I would probably have to double check the n's and the m's, the size of the array, but I actually didn't do that at this very moment for whatever reason. Uh, and then now I'm like, okay, what is the shift operation actually is? Because initially my thought was that I could just, for some reason, I read this as just shifting to the right. So then you could just mod k by n, where the n is the width. Oh yeah, the width. But I guess it's more complicated than I was like, okay. And then now I'm looking at the constraints and also just one example, like the another example anything. And I was like, oh well, maybe if I'm gonna do things in Python, I should do it in C++. But I was like, yeah, it's okay. I think I also at this point pull out a calculator just to make sure that 50 squared times k will be fast enough. Uh, but yeah, well, overall, this problem was pretty straightforward. I think the hard, I think maybe a better workflow here would have been nice, um, but did pretty okay. Because I have to keep on scrolling up and down, and if I had like two monitors or something, this would be a lot easier. But I'm still doing everything on my single laptop with too small of a screen. So what you see is what I see. So I had to keep on looking at the rules. I actually end up copying and pasting the rules down here, but could have done that a little bit earlier probably as an optimization. Not a big deal, but yeah, and I also changed the notations to I and J so I don't confuse myself that much. Even though sometimes I use X and Y, but it's not again, it's not a big deal, but having uh, uh, being consistent in your notations helps. I was here trying to do like the inverse operation of of what the directions tell you. But I was like, okay, let's just do exactly what the directions tell you instead of kind of trying to be tricky with the off by ones. So that's what I end up doing, and then I, write additional things here to, yeah, to kind of just fix that. But overall, this is essentially a copy and paste from the problem statement, even on this particular part, right? So yeah, pretty straightforward. So I had a typo that cost me maybe not that long, just like a minute, maybe not even a minute, but well, not a typo, but just I didn't do it. I think I was just rushing a little bit. Now I'm like deleting while I'm testing. I mean, I test anyway, so I don't try to rush it that much. At least I don't skip testing because I get a lot of wrong problems. Now while I'm doing that, I'm also trying to get more, and I was like, oh, one time error. Why is that? But then now I'm pasting another example. So I was like, okay. Wasn't super sure. But let me just run the other one, and that also confirms it, even though it didn't really run the second day. So I was like, oh, okay, is this? I think I meant to do that when I was typing it, but I just forgot in my rush a little bit. And then now just put one more. And everything looks good. I was about to submit this. I mean, I'd make a minor optimization here that I end up testing. So I guess in theory, I cost myself like 100 seconds. Oh, sorry. Maybe not that long. Maybe like 20 seconds, but maybe like 30 seconds. Just waiting for the results and then submitting it. Not a big deal because it doesn't even come up with the biggest cases, but I just figure I might as well save some time. Okay, second, find elements in a contaminated binary tree. I think the trickiest part about this problem for me was just kind of reading it. I didn't know what's going on. But yeah, I mean, I'm just still reading. I mean, past Larry is reading. Future Larry or current Larry that you're listening to, knows what this problem is. But right now, I'm just reading a lot, and I think I actually, to be honest, read the problem and didn't really understand it, or like, yeah. And I had to look at the examples to kind of see. And I think this problem did a good job of kind of having a great examples and with illustration. I think it was just sometimes they try to get you that way, or I don't know if it's necessarily intentional, but they just don't give you that extra understanding thing for visualization. But I think at this point I understand the problem, which is that just construct a tree and then see different elements in the tree. Which immediately I was like, oh, maybe I should. Well, initially I was going to try to use an array and then extend it when we get more variables. But then I was like, oh wait, because I think I saw 10 to the 6 as the target, and then I was like, what if you have some crazy tree? Though I guess the depth is actually only up to 20, so it shouldn't be that too crazy. But well, yeah. But I was like, all right, just use the lookup table, and then, in fact, I could have just used the set, but I didn't even do that. Like, oh, I don't need this. I just use. And this is like actually the canonical way of constructing an array representation of a tree. So this is relatively easy to follow. And you just have to go do it recursively with the recursion function. Just double checking my assumptions on by rereading it. And in theory, if we needed the node, like a find, we need the node for the find, then we could have also put down the lookup table. But actually, we didn't need it. So we just set the lookup table to be true, and then I was going to do something even funkier, but I was like, no, I don't even need that. And there you go. And that's mostly it. I mean, I think I tried to do well, at the very least, I test the inputs as usual, but yeah. True false. And now the third problem, greatest sum divisible by 3. I think immediately I knew that this was dynamic programming. I mean, I think I've been not recently, but I think I did a similar problem about 3 weeks ago, maybe a month ago now. And it just it is the same problem of kind of you know. So I would define it as yeah. Given this element, and it is the last element in your sum input, what is the best that you can do, right? That's actually a terrible explanation, but I was just, but yeah, I don't really. I think let's see how long I took on this one. I took up. I'm taking 6 minutes on this one, because I had some. I did some math wrong, but and you could see it in a little bit. But it's just the states are that for the current number, if this number is the last number in the list, what what is the biggest sum with that, with one of the three states, which is the number that is the remainder after 3, right? And we only care about the 0, kind of, at least at the end. But we still need to keep track because basically you can think of it as actually like a final state, a timeline where you go from 0 plus a number, like for some input number, it goes to x, which when the remainder is x mod 3, obviously, and then you kind of do it that way, and then you kind of keep on doing that in new best, and yeah. And actually, I think I could have illustrated this a little bit better if I had used a two-dimensional dynamic programming where it'll be O of n times 3. I mean, I know, but n times 3 in a way. But I did this kind of it's common optimization to kind of take in this case an order of n away from the space, because you can see that this is O of 6 space or one constant space. We only need 2 arrays of size 3, and then that's mostly it. And I had some like mental thing about like what am I doing, but then I cleared it out. I don't know. I think if I had a two-dimensional array, I would have got this a little bit, but I was trying to do that optimization in my head and end up spending, I guess, like 40 to 50 seconds on this, maybe even a little bit longer. No, that's not right. No. Yeah, I think in this one I had some confusion about which direction to go, and that's why you see me doing the +2 +1, which I guess end up costing me about 40 seconds as well, ish, give or take. But this is mostly it. I mean, I do fix this later. I think usually I write it the other direction, and that's why I got a little bit mixed up. But now that I see what I'm actually doing, but yeah, but I also figured that I don't have that many craziness. I just print out the weight just to see, but and I was like, oh yeah, I was like, I don't know the numbers, but this may be a little bit too small, so let me double check by adding some stuff just in case. But And I was like, oh, this is still wrong. And I was like, it must be the 1 and 2. I mean, there's not, didn't really have many choices to do it. Or like, there's not that much typo possibility. So I think that's the thing. That's the thing about keeping your code clean and short is that, like, if you have a typo, there are not that many places to hide. I mean, if your logic is wrong, that's another story, though, which maybe is a little bit of a foreshadowing. Yeah, and I checked the answer. Looks good. Coming out of prints, done. So I was very excited at this point. I was like, okay, 15 minutes in, something like that. 14 minutes in, solved 3 of the 4 problems, and actually didn't see what rank I was at, but I think because it didn't update in time anyway, because it takes like a minute after your submission to update. So I think I was at the top 20 at the time, roughly. I mean, maybe one of the viewers could kind of correct me. But yeah, I looked at this problem immediately. I knew that this, well, at least at the time. So I actually have a misread here. I thought it was the number of moves, which is different than the number of pushes. But from here, I knew immediately that this was, or at the time, a depth first search problem. Or sorry, a breadth first search problem, BFS. And essentially, I spent most of my time start typing. Let's see how long I took. But I assumed that, and this is wrong, by the way. And I'll and I actually explained this at the end of the stream with even an example. But basically, I was trying to do a breadth first search where the states is the position of your character and the box, right? Which is fine because it's a 20 by 20 grid. That means you can only be up to 400 square places. So it's 20 to the 4th. So that's the number of states. So you could definitely breadth first search it in theory. And that's what I end up trying to do in the first half. Let's see how long I take. I actually don't, because I end up submitting it incorrectly. I actually don't know how long I take. But that's the idea. Right now I'm just parsing out the starting position and the starting position and the box, and I think I later also parse out the end position, but here I'm just keeping my state management, no big deal, or like there's a standard for breadth first search, which I will remind you that it is wrong. Don't try this at home, or at least if you try this at home, make sure it's for the right problem. Yeah, here I'm just kind of looking. I think at this point, I was just looking around to see if you could get outside the borders, because in all the examples they close off the border so you can't be outside. But I didn't find any indication that you can't, so I was like, okay, fine, I'll check. I mean, I think it's probably a good habit anyway, to be honest. But I was just trying to be a little bit lazy, which is, I don't know how I feel about it. Mistakes were made. Here I'm still double checking. But right now, still very standard breadth first search. I I think I was actually also like my adrenaline was running at this time. I thought I was, because if I could finish quickly, and at this point I'm about 19 minutes in, and I have no indication that like I would run into any issues. And here I was like, okay, should I use the grid as the, because you can also parse it out, but then you have to, like, yeah, because you have to check for like S and B and E, I think, for end and stuff like this. So I was just like, okay, let's just convert them to dots, so then we could, after we know where they are, it's fine, right? Yeah, also, okay, maybe not yet. And right now, I mean, I knew that it was going to be breadth first search actually at this point, or I mean, like again, this is wrong, but at this moment, I thought it was going to be breadth first search, but I actually didn't know how the mechanics about pushing the box, and I'm very lucky, or maybe I don't know, thing that I just noticed. I think like about now, I mean, or at least after I typed this now, I was like, okay, because at first I was just going to handle the person moving and not worry about the box yet, like step by step, right? But I was like, how do I handle the box? So it turns out that because of the way I did this, or yeah, and I keep track of the end. I was like, oh, should I put track for the end here, or maybe later? Okay, maybe later. But I also noticed that I think about now I was thinking about like how to handle the box, or maybe like in a couple of seconds. I was like, okay, if it goes to the box, like if the person goes to the square where the box is, then actually the box could just move in the same direction. So I didn't have to do anything extra crazy here, which speeds my time again as well. Still standard stuff with the precision and the boxes, the yeah, as the end precision. Yeah. I think, yeah, I mean, I think I'm okay, but I think I could have done a little bit tighter on my code here. Just getting the distance out of the box. And I, maybe not at this current point. A lot of times you actually also put the distance in the queue, but for breadth search is equivalent because you're always going to see the, you're always going to, like the earliest you can be at a cell is the first time you see it, which is a little bit of a foreshadowing if I ever see one, but and that's roughly it. Oh, and I have to keep track of the notes today. So in theory, if I had gotten everything, or like if I had gotten the algorithm right, and there's still a lot of typing, but I would have gotten it at 24 minutes, maybe a little bit longer, 25 say. And if I had finished in 25 minutes, I would have been actually third or fourth. It is not what happened though, so don't worry about it. But looking at the time, that's so I was making very good time. So actually looking back, it's a little sad, but what could have been. I think I didn't take count one case here, which is the. I think I looked at that result and I was like, oh, well, first of all, it was the number of moves, so then I had to make that change. But I think if I was more experienced here, then I would notice that because of that change, the invariant is actually no longer true. But I was still kind of just like, I was like, okay, let me just try to finish it as soon as I can. Maybe I could get top 10. At this point, I actually didn't know this at the time, how hard this problem is. So I was like, okay, let's just get it done as soon as possible and then worry about stuff later. I think even at this point, I knew that I need to take care of the return -1 case, but I was just like, let me finish. And it's very hard to look at all this missing on the clicking. Man, that was very frustrating, actually. But yeah, just I mean, I'm gonna always need a test cases, so it's not a big deal. And I ran it, and I was like, and I was expecting to see none because I think, yeah, and I was like, if I don't see none, then that means something else is wrong, or an exception depending on how I handle it. But thankfully, it did okay. But yeah, now I did spend extra time to put in the extra test case, even though, like I said, I mean, even though I know that I was trying to finish tops, um, at the end of the day, five minute penalty is not worth like the extra, I guess, 30 to 40 seconds. For this, maybe for this one, I should have been better, or like I had more confidence in this. If it's wrong, it's wrong. But yeah, so I was like, okay, let's submit. Cross my fingers. This is at 26 minutes. I was like, oh no, got something wrong. Um, so if this had been right, I would have been fifth or so. So close. But I look at the test case. I should put it on a notepad, like not physical notepad, but like a notepad app, just so that I could visualize it. I could have done it here, I guess. But I was just trying to see what could be wrong, and I didn't really visualize it. I guess I didn't do that. Yeah, yeah, but I do change to a notepad, and when you see it, you can see that it is away. And I was like, oh, 16, not bad. But I finished quickly. Actually, yeah, only 3 people had submitted at this point, so I could have been like, you know, top 10 probably. But I was wrong. So, but turns out like if I look at the code at the end, like it's not that far different now. So where it could have been, it's not like I had to write that much more code or different. It's just that yeah, I think once I saw kind of this code, and the thing is that it turns out that because you could get to states with more pushes, but earlier in the breadth first search, if that makes sense. So I explained this a little bit in the review of my review of this problem, and I have more visualization there. But suffice to say that because of this, that's not good enough. And I was like, well, the only thing I can do here is to convert this into a heap. Well, I guess I print it out first just in case. So maybe I didn't do this on Notepad first to visualize it because I was like, how am I going to debug this? I think was my issue because this is such a big thing and there's no user visualization. I'm like, okay, this is useless. But yeah, but the idea that I've come up across at some point soon is that yeah, it's more similar to yeah, I need a heap is the short answer. Like so that you're always doing it from the min distance away. I was also looking at the high score just to see if like maybe it's harder than I thought. So like maybe there's some weirdness. Sometimes you get some hints because at least from me, other people are usually better than me, right? So like I could see from how long they take that, like I could maybe gauge the difficulty from there. So I didn't dwell that much on it on this time, but that's a tactic that you can use to kind of sometimes. But yeah, at this point I was like, okay, I need a heap. So I'm 28 minutes in. So even if I had gotten it in say 3-4 minutes, I would have still finished in the top 10. So I had a lot of more time. Well, actually plus the penalty, so maybe not. But still top 20, say, which would have been great. But I made another critical mistake here, where, and again, this is why familiarity with your your code matters, right? Or with your library, it matters because for some reason I thought the Python heap is a max heap, but it actually turns out to be a min heap, which is what I want. But because of this, I do like some silly thing that end up spend until like I was like it can't be anything else, or like I added a lot of debugging, which you'll see in a minute. But I think remembering what kind of heap it was cost me about 10 minutes, to be honest. So not so something that have to be really be better about. Um, and now I'm just changing it to kind of probably should have just typed it out. I think I spent more time like going back and forth and instead of just like do exactly what we need. But see here, because I thought it was a max heap, uh, we yeah we want the min heap, and if we had a min heap, then the negative would have fallen to the top earlier with the smaller number. Uh, or yeah, I mean, because you want the smaller number to go first, and here I just type out a box, which probably I should have just typed everything out. Have a minor typo, but that's fine. But sadly, I would have actually been done now if I had a min heap. Here's some properties that I wasn't super sure on, but I actually wouldn't have changed the thing if I had done it correctly. So that's actually a sad part. So I would have, if I had probably recognized that this was a min heap, then I would have gotten it now, which would have been top 20 at least, top 15. Because that would have been just true by default, as it turns out. But I didn't know this at the time. I think one thing about not resetting and not rethinking about it, from like maybe I should have taken 1 minute to kind of think about the changes I need to do instead of kind of just do it in the moment. Because if I had done it, then maybe I could have kind of put everything together. But I have, as a result, I have about 2 or 3 ideas that were good, but but um, but I wasn't able to look at the bigger picture, and it cost me a little bit more. Bad copy and paste. There's a lot of silly mistakes after what was otherwise a good contest. Here I didn't know what's going on, so let's see how long have I not known what's going on. I think it ended up costing me about a minute on this one, where I just, because I was changing everything, I kept independent. You'll see it pretty soon. But I just didn't know where it could be wrong, because it's not a common message, or like the bug isn't where the exception is. So was like, am I pushing to heap right? Oh, there's the pen. Whoops. And I think here, if everything, here I could have submitted if I had recognized that was a min heap. So definitely top. Okay, I mean, maybe I shouldn't obsess over it. It's about 35 minutes in. But because I didn't realize, I was wondering if but instead of questioning myself on whether the heap was of the right persuasion, I thought maybe that my new assumption was wrong, and I wanted to, and I'm debugging this for the next 10 minutes. But yeah, but I mean, and you could kind of see my struggle, and I do a lot of debugging, try to figure it out. But the short story is that I was maybe a little bit spoiler, but you could see that I was popping things off a little bit too aggressively for some reason, and it took me a long time to, like 10 minutes to kind of figure that out. And then when I do a lot of print statements, and then I was like, okay, this doesn't make sense. And then I realized that it was a min hip, and then once I fixed that, it was good to go. Except for I had another time limited because I was playing around with the idea of refreshing some states on every level. But yeah, what a potential thing. But maybe hopefully I could keep this up, and then I'll do better next round. But yeah, I think the other Larry, will take over now. I'll see y'all later. That's annoying. Whoops, was using a dumbass. Mm. Maybe it is. Wish they gave me the end zone on that. Just to wait. Okay. So many submits. So it's gonna take me out the top 25. I was so fast on the other ones, but I misread. Well, not misread. I was just wrong on the, and I needed to use a priority queue. Some discovery there. I learned a lot. So that's not bad. But the 2 submission errors. Okay. Let's see. I guess we'll do 10 minutes. I mean, yeah, it's not great. I guess it's not updated yet, actually. But either way, so so yeah, I have like 10 minutes to see where I land. Just could have been 25. Yeah, if I had one fewer mistake, so if I didn't time out, been top 25 ish, maybe. I don't know what time left. But yeah, cool. Let's just go over the problems. So this should probably go down for like a couple more, but should have recognized that a little bit earlier. So, and I was explaining what I got wrong. Yeah, shift 2D grid. This was pretty straightforward. It's just literally simulation, which is do what they tell you. Though it is very easy to get off by 1, so so definitely double check there. But it's just literally follow these rules where they tell you exactly, and then you just map them, and then that should be right. Pretty straightforward here. Find elements and connect. Oh yeah. So here you could construct the entire tree and then see if you could find the element back. Seems to be pretty. How long did I take? I took 4 minutes. Yeah, it seems pretty straightforward. I mean, you just kind of go left and then go right, and then you I have a lookup table that goes to see if it so you could actually do. I mean, actually you could probably do. I was going to say you could probably do just traverse the tree, but maybe that will actually time out because in a very weird edge case situation. But yeah, it's just going down the tree, left, right, and then just kind of memorize, if you will, what you kind of seen. Great. I think I skipped one. So this is the dynamic program problem. I took about 6 minutes. I could have gone a little bit faster. I just got a little confused because I was actually. So the way you can do this is actually you could have I guess that actually memorized could have been okay. It's just 3 times n dynamic programming where yeah, the 3 possible states, which is 0, 1, and 3, which is the mod number, right? Like, and when you add them, you just take the best of. I'm not explaining this part actually, but yeah, but you just take the best choice that you can take at any given time, given that that was the last mod, right? So that's roughly it. I mean, that's the general idea. The thing is that and you start with 0 because that's where the new thing is, and then you just take, for example, the current number is equal to the previous. It's a little, yeah, because that's the. I thought this was actually reworded, but I mean it's submitted, so I guess it's okay. But basically, yeah, take that the last best number. So basically, you keep track of 3 states. One is the highest sum, given that all the numbers you've seen up to this digit, up to this number, the sum divided by 3 is equal to, the mod 3 is equal to 0, 1, and then 2, and then this is just a straightforward dynamic programming thing, and yeah, and I did the I guess all of one dynamic programming. I should have just undo that, and maybe it saved me a minute because I was a little confused. Here, well, a couple of things is that I misread the problem, but I probably should have. Yeah, so I misread the problem for kind of just distance as the number of moves, but very straightforward to kind of do it for number of pushes, and then I got that out pretty quickly. Actually, I mean, I'll have to go through the logs to see how long I took, but unfortunately, that's because and the regular breadth first search would be optimal if it's moves, but not for pushes, because there was a case which it was not in the example cases, so I guess I would have always gotten this wrong, and it took a long time, which is this. Okay, fine. So it's something like this case, so maybe it's actually not too difficult to see in theory. But in breadth first search, your start thing would be here, or something like that, and then pushes. Oh no, wait, oops. Your boxes. Okay, so in here, your start will go below the box. Oops, man, it's highlighting. Oh, because I'm highlighting the area. That's why. So it'll push the box up because that's when you do breadth first search on moves, that's the closest, and that's going to be a longer way, right? That's why you get 7 for that instead of 5. So what I did was, well, now we knowing that you could just put the heap on the distance. So I put distance as kind of part of that as well, so that and distance in this metric is just the number of pushes, so that you'll always do all the pushes of all the yeah. So in this way, it gives you the ordering that allows you to do them in the right order, so that even though you're here, you pushes up. That will also give you the state that you could also be here, and then and pushes down at the same level, if you will, and then that gets you the answer. And I did a thing where I wasn't sure, so I wasn't sure whether you need to reset the scene state before that, but looking back, I didn't need to. So that's why there was a second submission with the time limited. But overall, it's a cute set. I should have done this a little bit better, or a lot better in timing. I have to go back to see my timing metrics. But yeah, I'm going to review other. Yeah, stay tuned. I'm going to review other people's code in just a minute.